called a croquet ball, MA, and let's call the other one, or let's call that A, and let's call the other one B, right? Masses MA and MB. And so from equation 9-8 from the book for elastic collisions, we have head-on collisions. We have the velocity of A minus velocity of B. Initial velocities will be equal to the negative of the difference in their final velocities, okay, minus VA prime minus VB prime. All right. And so VB is 0. Initially, the other ball is at rest. And so, and also, VB prime is 1/2 of the original, of the initial velocity of the croquet ball. So that's 1/2 VA. And so A prime is just negative 1/2 of VA, the original velocity of ball A, the croquet ball. Right, so now we invoke momentum conservation. So this is part A. We invoke momentum conservation. Initially, you have MA VA as the only momentum. The other ball is at rest. That's equal to MA VA prime plus MB VB prime, and VB prime is 1/2 of VA. Okay, so VB prime is 1/2 of VA, and VA prime is 1/2 of negative 1/2 of VA. So MA VA is actually negative 1/2 MA VA plus 1/2 MB VB. We multiply both sides by 2, or MB VA, I should say. We multiply both sides by 2, and what we get is 2 MA VA plus, bring this term out to the left, plus MA VA is equal to MB VA. Therefore, MB is 3 times MA because the VA's cancel, and thus it's just 3 times 0.28 kilograms, making it 0.84 kilograms for the mass of the second ball. All right, and in part B, we want the fraction of kinetic energy that's transferred from the original. So we just take a ratio, actually. Take a ratio of ball B to ball A. And so for ball B, you have 1/2 MB VB squared, obviously. Ball A, you have 1/2 MA VA squared. And so, VB prime squared. So the 1/2s cancel, and you have MB is 3 times MA, so that's 3 MA over MA times VB prime is negative 1/2 VA squared, whole squared, over VA squared, which is just VA squared. And so the VA squares cancel, the MAs cancel, right? The VAs cancel. You're left with 3 times 1/4, so that's 3/4, or 0.75 is the fraction.